Now, do you see these little black spots on the diagram? Each one of those is an application, and each one of the applications sends data or receives data from other applications. That's what these lines are in this diagram. And how would you like to be a manager trying to make decisions on the data you have in your corporation? And the answer is it's almost impossible to make appropriate decisions. Why? Because when you look at the data in the corporations, the same piece of data can have different values. In one place, it can be $2,000. Another place, minus 100. Another place, $500. And so trying to use the data in this spider web environment was something that was impossible to do. And the bigger the environment that it grew, the worse things became. And so this is the origins of data warehousing. People realized that building more applications was not going to solve their problem. So this led to the first data warehouse. And what we did was we went into the spider web environment and split it into online transactions and data warehousing transactions. And the data warehouse, the definition that we gave, was something that was subject-oriented, integrated, non-volatile, time-variant, collection of data in support of management's decisions. That's the definition of a data warehouse. And why do we have data warehouses? Because we found out that this spider web environment was not usable for supporting our information needs in the organization. So this is where the notion of a data warehouse came from. We then discovered that building data warehouses was not a particularly easy thing to do. We discovered that trying to write programs to bring data from the application to the data warehouse was something that required a lot of work. And so we developed technology for it called ETL, and that stands for Extract, Transform, Load Technology. And so that's what we did. And with the ETL technology, we were able to automatically build the programs that were needed to bring data from the applications into the data warehouse. Now, there's something else that's going on here that you need to know about. It's not a matter of just bringing data from the applications. It's a matter of transforming the data. Now, what do I mean by transforming the data? You see, in the applications environment, the programmer and designer could call data anything they wanted. And one application would have the gender of a person as male and female. The next application would have gender of a person as an M and an F. The next application would have gender of a person as a 0 and a 1. So each person building an application could decide what they wanted to do with the data. And that was fine for the application. But once you start to merge the data from the application together, you needed to be able to choose one way of representing the data. And so if you chose M and F as the representation of gender, then where you had male and female and a 1 and a 0, you had to convert those values into the corporate values. So when we see a data warehouse, people oftentimes think that we're just moving data into the data warehouse. In fact, we're transforming the data from an applications foundation to a truly corporate foundation. And so that's what's going on here. And Once we had ETL built to where we could do automated transformation of data, then it became fairly easy and fairly quick to build a data warehouse. One of the things that may surprise you is that in the early days of data warehouse, the technicians and the IT community absolutely rejected data warehouse. For whatever reason, they decided they didn't like or they didn't want data warehouses. And so this is kind of interesting because today we don't really find that. But in the early days of data warehousing, trying to talk to the technical world or the IT world about data warehousing was something that you didn't do. So because nobody, the IT person didn't think it was their job to build a data warehouse. And so so how did data warehousing get started? The data warehousing got started in the world by talking to the marketing and sales organizations. The marketing people recognized the problems and the need for integrated corporate information. And the salespeople recognized the need for it. And so what we found was that the people in the business person was the person that started to want and love data warehousing. And it was the business person that then told the IT person, go build a data warehouse. Now, it's also kind of interesting to note, in the early days of data warehousing, the world was just starting to have what are called cellular telephones. It's kind of hard to think that in today's world, there once was a day where we didn't have cellular telephones, but it's true. Once upon a time, not so long ago, in the world, we had a world without cellular telephones. And one day, the world discovered that it could build and want cellular telephones. And so these companies sprang up, and they wanted to get as many customers as they could get. And to some extent, that competition is still going today, but it's nothing like it was in the early days of cell phone. And the marketing people in the cell phone organization discovered that they could use the data warehouse to understand their customer. And by understanding their customer, they could start to be very effective in getting market share. So it really was the cellular telephone industry that started the first mass acceptance of the data warehouse environment. This is what how it happened. So data warehousing began in the marketing cellular environment, and then it spread to other industries, and then it spread to the world of technology. Now, in today's world, you don't find that much anymore. You find that technicians understand that they need a data warehouse, but in the early days of the industry, it was the technician that was the enemy of data warehousing. Now, as we were building data warehouses, we discovered along the way that we needed something else to help us. And that other thing that needed to help us was something called a data mart. And a data mart is really a departmental understanding of data. So we had finance looking at their version of data. We had sales looking at their version of data. We had marketing looking at their version of data. And the data was taken from the data warehouse and was customized to the needs of the given departments. And so this architecturally was something that happened, that we discovered that we needed this thing called a data mart. Then along came something else called the data vault, which is really a subset of a data warehouse. A data vault is a way of building and maintaining data warehouses in which there is a very high degree of accuracy and integrity of data from the source of the data to the data vault. And so when I think of data vaults, I think of data vault as being another way of building a data warehouse. And data vaults are useful for organizations that have got to have a very tight control of data. Hospitals, military organizations, organizations that the banks and so people like that are the ones that need to be able to have a tight control of where the data came from and what it's going to be used with the data. Because once the data is in the data vault, you can always go back to the source of the data and find where the data came from and how it got into the data vault. So that was another advancement in the world of data warehousing. Then the world discovered something called big data. And with big data, we had technology that enhanced the volume of data that a data warehouse could store. Now, data warehouses could always store a fair amount of data, but there was a limit to how much data a data warehouse could store. And then something called big data came along and said, okay, now you can store an unlimited amount of data. And for some people, that was very appealing. The problem is that the people in big data didn't recognize the difference between technology and architecture. You see, a data warehouse is an architecture and big data is a technology. And we could have another whole long discussion on the differences between an architecture and a technology. But the people that came along in big data were so excited about their technology that they came along and said, aha, big data is going to replace a data warehouse. And that was never true. That big data, you could build a data warehouse using big data, but there is a fundamental difference between the technology of big data and the infrastructure that we call a data warehouse. So in terms of the history of data warehousing, we have to tell you that big data came along, and I've always thought that big data was a perfect way to treat the problem of volume of data, but the people, the data scientists, and the people that use big data for whatever reason, they decided they didn't like data warehouse and that big data was a data warehouse, and that simply was never the case. Then along came a major new advancement, and that major new advancement was something called textual data. You see, when you take a look at data warehousing has always been something that was based on structured data, usually transaction-based data. That's what data warehouse was based on and what it is today. However, one day we woke up and found out that there is a lot of other information in the corporation that is not getting into the data warehouse, and that information is textual information. Now, where do we find text? We actually find text in lots of places. We find text in corporate contracts. We find text in conversations. We find text in 800 numbers that organizations have to call companies. I assume in South America you have the same thing we have in the United States. We have companies in the United States will list what's called an 800 number, and anybody can call that 800 number and have a conversation with the person of the corporation. So whether you're a customer or a prospect, you can just simply pick up the phone and call the corporation. That's another place where there's valuable textual information. But there's lots and lots of places in the corporation where there's textual information that isn't being included in a data warehouse. And so we now have a different form of ETL. We have something called textual ETL, and textual ETL is the technology that allows us to go in and read textual data and turn that into data for a data warehouse. Now, who's this useful to? This is useful to a lot of people. A lot of corporations want to know, for example, what's being said about them on the internet. What do their customers think about their products, the company, et cetera, and so forth. And that's important information. Another place where we find textual information that needs to be looked at is in medical records. You look at medical records and you find out that once you can take the text that's in medical records and turn it into a database, then you can start to do research and analysis you could never use before. Another place is corporate contracts. I can't tell you how many times I've talked to executives in corporations around the world, and I ask them this question. I say, how many of you know what's in your corporate contracts? And nobody does. Nobody knows what's in their corporate contracts. And then I say, don't you think it's important that you know what's in your corporate contracts? And the answer I get back is, gee, Bill, there are millions of contracts. How can we know what's in a million contracts? And I said, well, if you put the text in those contracts into a database, you could know and you could write simple queries. So please don't tell me that you can't put data into a corporate contract data into a database, because you can. So there are a million uses for the ability to take text and put text into a data warehouse. And that revolution of putting text into a data warehouse is occurring now, and some of the results we're coming up with are truly spectacular. Then there is something that is related to a data warehouse that is something that is, again, just merging on the horizon. And that's something called a data lakehouse. And so what is a data lakehouse? Well, somebody sat back and recognized that there are different kinds of data that's out there in the world. There's transaction data, the data that comes to us from transactions. There's textual data, which we just got through talking about. Then there's analog or Internet of Things data. Now, what is analog Internet of Things data? It's data that's typically created and generated by a machine. And you see the other data that we have, textual data is created by somebody writing something or speaking. Transaction data is data that's comes to us from people doing business, buying something, selling something. But there's another kind of data that's out there, and that's analog IoT data. And so what is analog or IoT data? Let me give you some examples. Suppose you are in a factory and you've got all of these machines that are making something, whether it's cars or a part or are making something. And what you can do is you can take the measurements from each of the machines for each of the parts being produced and measure and keep track of that data. So it's machine generated data. Let me give you an example. My first introduction to machine generated data was in a steel mill plant. And one day I was in the steel mill plant, and I don't know if you've ever seen steel being made, but it's actually a quite interesting process. They put all of these raw materials into a pot, and then they heat the pot to a very, very hot temperature, the materials turn into a liquefied form. Then they pour that liquid form into molds, and as they're pouring it through the molds, they measure the heat, the chemical content, the speed with which things are flowing. There's all kinds of things that they measure to make sure that the manufacture of steel is done properly. Well, each time they measure this information, they create a new record. And so in a day's time, in a steel mill, you may create 100 million records based on how much you're producing and the speed with which you're producing it. And engineers use this data for the purpose of controlling the quality of the manufacture of steel. That's one thing they do with it. There's a lot of other things they do with it as well. So there's a whole different world of data that's being produced over here in the analog IoT environment. And now there's lots of forms of analog data. Another form of analog data that's kind of interesting is when a train starts to travel across the country that the tracks are on. They keep track of the cars that are being pulled by the train. They've got a little electric eye that sits there and reads the number on the car, and in doing so, they have an electronic track of the cars itself, and they can determine such things as how fast is the train traveling, how efficiently is the train traveling, where is the location of any given car. There's lots of information that's created by machines. So we see then that somebody sat back and recognized that there are different kinds of data that come from different places. We have transaction data, which is you cashing a check in the bank. We have textual data, which is you having a conversation with somebody in a company, or we have analog data, which is a machine that is building something for your consumption. So these are the three kinds of data that we have. And somebody came along with the idea of, gee, can't we merge this kind of data together? Wouldn't it be interesting to take this data and create a higher form of a data warehouse, something we call a data lakehouse? Now, the first thing that you notice when you look at this data is the volume of data comes at you like an avalanche. It looks like that you're standing there in a mountainside 1 minute, and in the next minute you're swept away by this amount of data, because the volume of data that we have when we put these three kinds of data together is simply enormous. No way around it, simply enormous. And so with that, we create something called a data lakehouse. We can take the transaction data from ETL, taking our structured data and applications using ETL to create our structured transaction data. We have textual data, where we have the ability to take text and take the text and put it into a data warehouse form. And then we have analog data. Now, analog data is very different from the kinds of data that we're used to dealing with. In some ways, it's a lot cruder. In other ways, it's even more sophisticated. With analog data, we typically have a very large amount of data, very, very large amount of data. With analog data, we typically don't have the nice record layout of keys and attributes, keys and attributes and things like that. And so merging the data between these three different worlds is a real trick. That's where the complication comes. we find out that when we start to look more closely at this, we find out that there are such things as universal identifiers. Now, what is a universal identifier? A universal identifier is something that is found everywhere. It's something that no matter where the data comes from or how it's generated, that particular understanding of data is simply true. Let me give you an example of a universal identifier. One of the universal identifiers is the country. That you're now in South America and you're saying, gee, Bill, I've got all of these machine kinds of data. How can I distinguish between different machines that are creating data for me in South America? Well, one way you can create them, that difference is to say, gee, some of these machines are in the country of Colombia and others of the machines are in Peru or Chile or Argentina or Brazil. That one way we can distinguish things is by country. But there's a lot of other identifiers. If we were talking about people, we could talk about such things as the age of a person, the gender of a person, the race of a person. Every person in the world has those common characteristics. So those are how we can bring these types of data together is by the usage of universal common identifiers. So that then is a conversation about data warehouse, where we've come from, and where we're going in the future. I hope that you found this presentation to be interesting and useful. We'll be more than happy to have questions if you have any questions. Now tomorrow I'm going to be talking about some of these subjects in a great deal more depth. So I want to thank you for your time today. And if you would like to have questions for me, I am here to try to answer them. And we'll see you tomorrow then.
Okay. Yes. Thanks a lot, Bill, for your participation for the Julius Garavito Colombian School of Engineering and DEIMA Colombia chapter. It was very important to have you, your presentation here as a special guest and an expert of data warehousing and business intelligence knowledge area. We thank you and thank our Lai, a computer scientist who has been recognized as the father of data warehouse. Yes. You have written 60 books published in 9 languages. Wow. Was named by Computer World as one of the 10 most influential people in the history of computer profession. Tomorrow we will have the opportunity again to share with you, Bill, in a demo of data architecture beginning at 9 a.m. Okay? Thanks a lot.
Okay. Thank you.
Bueno, pues les agradecemos a todos mucho la participación y los esperamos para mañana, que también tenemos una conferencia con Bill a las 9 también, creo, chicas. No sé si de pronto, sí es. De pronto Fabiola nos quiera contar, bueno, es que no supe si Fabiola estaba, porque ahorita pues esta tarde tenemos de nuevo una conferencia y pues los invitamos y les damos muchas gracias a todos por estar participando con nosotros y continuar con este simposio. ¿Tú quieres contarnos, Fabiola?
Sí, claro. ¿Cómo están? Bueno, muchísimas gracias por acompañarnos en estas conferencias. A las 11 de la mañana tenemos una conferencia que se llama Mitos y realidades y buenas prácticas en gestión de datos para la innovación, en la cual voy a tener yo el honor de guiarlos. Ojalá nos acompañen. Esta tarde vamos a tener a Milán Sánchez, que nos va a hablar sobre gobierno de datos y gestión de datos en casos específicos, organizaciones específicas. Creo que ya Marco y Vicky les contaron la conferencia que tenemos también a las 4 de la tarde con Juan Pablo Gómez, cofundador del DAMA. O sea, voy a recapitular en orden. A las 11 de la mañana, mitos y realidades en innovación y gestión de datos, que los acompaño yo. A las 4 de la tarde, cómo monetizar, gobernar, gestionar y medir los datos como activos para generar ventajas competitivas, con Juan Pablo Gómez, cofundador del DAMA. A las 5 de la tarde, casos de éxito en la región, organizaciones impulsadas por datos e inteligencia. Milán Sánchez, de Microsoft Latinoamérica. Entonces tenemos esas 3 conferencias. La primera, como les digo, es a las 11 de la mañana. Los estaremos esperando. María Alejandra, si nos puedes compartir el link de la conferencia de las 11, y en esa conferencia les compartiremos de nuevo el link de la siguiente, que es la de Juan Pablo. Así digamos que puede ser un poco más fácil. Entonces los esperamos en la de las 11. Y mañana tendremos nuevamente a Bill Aymon y tendremos a Germán Cortés, que es vicepresidente de Membresía DAMA Colombia. Entonces, creo que son bastantes conferencias que se vienen y bastante interesantes. Por ahora, la siguiente los esperamos a las 11.
Que les agradezco a todos mucho la participación, a Marco y a Fabiola y a María Alejandra, y entonces seguimos y continuamos pues en la línea con el simposio. Muchas gracias a todos.
Okay, muchas gracias.